So the next chapter is ammonia. Ammonia molecular formula NH3, relative molecular mass 17. This is the electron dot structure or Lewis dot structure. It has a lone pair of electrons. This is showing the covalent bonding in ammonia. It's a covalent compound. Ammonia is present in small amounts in air and in traces in natural water. In combined state, in nature, ammonia occurs in combined form in many compounds such as ammonium chloride, ammonium sulfate, etc. Ammonia and ammonium compound, being highly soluble in water, do not occur as minerals. The pungent smell which one encounters near a decaying heap of organic matter or a toilet is due to ammonia. तो रेलवे स्टेशन का टॉयलेट, जैसे ट्रेन गुजरती है यहाँ से, you know there is a toilet, you can close your eyes and tell there is a toilet on my left. The smell, that pungent smell, that's what we are going to study today. Not the smell, but the compound behind it. Okay. But you know that smell, right? Public toilet wala smell. That is ammonia. It is produced due to bacterial decomposition of urea, which is present in the urine. So the reaction is also given here. CONH2 twice plus 2H2O gives 2NH3 plus H2O plus CO2. Forms of ammonia. Ammonia is used commonly in the following forms: gaseous form, dry ammonia gas; liquid ammonia or liquor ammonia. When dry ammonia is liquefied by applying high pressure, it is called liquid ammonia. I'm sorry, that is not liquor ammonia. Liquid ammonia is liquefied ammonia. And the other one which I'm talking about is liquor ammonia fortis. Liquor ammonia fortis. It is a saturated solution of ammonia in water. It is called 880 ammonia. 880 ammonia. It has a relative density of 0.880, less than water. It floats on water. It is stored in tightly stoppered bottles in a cold place. Laboratory bench reagent. Dilute solution of liquor ammonia is used as laboratory reagent. So these are all the forms of ammonia which we generally come across: gaseous, liquid, liquor, and laboratory reagent. Preparation of ammonia gas. General methods of preparation. Ammonia gas can be prepared by warming an ammonium salt with caustic alkali such as slaked lime or caustic soda or caustic potash. तो एक अमोनियम सॉल्ट ले लेते हैं, जैसे कि अमोनियम क्लोराइड हो गया, अमोनियम सल्फेट हो गया, और उसको किसी भी अल्कली के साथ हीट करते हैं. अल्कली इज अ बेस, वाटर सोल्यूबल बेस. कैल्शियम हाइड्रोक्साइड ले लो या फिर सोडियम हाइड्रोक्साइड ले लो या पोटेशियम हाइड्रोक्साइड, एंड इट गिव्स रिस्पेक्टिव सॉल्ट and water, and ammonia is liberated. So this is how general method of preparation of ammonia goes. Laboratory preparation from ammonium chloride. So we'll take an example of ammonium chloride, NH4Cl, and calcium hydroxide alkali in the ratio 2:3 by weight to form ammonia. So we have ammonium chloride reacts with calcium hydroxide, gives calcium chloride plus water plus ammonia. So calcium hydroxide and ammonium chloride, they react within this round bottom flask. They produce ammonia which is passed through quicklime, a tower of quicklime to dry it out, and we get dry ammonia by downward displacement of air. Remember, I'm sorry. Why downward displacement of air? Because it is lighter than air. HCl was heavier, this is lighter. sorry. Reactants means, oops. Reactants means calcium hydroxide and ammonium chloride. They are finely grinded and taken in a round bottom flask fitted in a slanting position, mouth downwards. रिएक्टेंट्स को फाइनली ग्राइंड करते हैं और एक राउंड बॉटम फ्लास्क में रखते हैं और उसको एक ऐसे स्लैंटिंग पोजीशन में रखते हैं ताकि उसका माउथ नीचे की तरफ रहे. On heating the mixture, ammonia is evolved. Precaution: the flask is tilted in such a way that water formed in the reaction does not trickle back into the heated flask and thus break it. मतलब एक प्रिकॉशन लेना है हमें कि फ्लास्क को टिल्टेड रखना है क्योंकि वाटर फॉर्म होगा रिएक्शन में, वो हमारे रिएक्टेंट्स को के साथ मिक्स नहीं होना चाहिए, नहीं तो वो ग्लास को क्रैक कर देगा. Drying of ammonia. In order to get dry ammonia, gases pass through a drying tower containing lumps of quicklime. Lumps of quicklime, that is calcium oxide. Unsuitability of other drying agents. Other drying agents like concentrated sulfuric acid, phosphorus pentoxide, anhydrous calcium chloride are not used as ammonia, being basic, reacts with them. So ammonia reacts with sulfuric acid, ammonia reacts with phosphorus pentoxide and also calcium chloride. So they are not used. Only quicklime is used as drying agent. Ammonia is collected in the inverted gas jars by the downward displacement of air because it is lighter than air. Vapor density is 8.5 and that of air is 14.4. And it is highly soluble in water and therefore it cannot be collected over water. So these two reasons why it is collected by downward displacement of air. The reactants NH4Cl and CaOH twice are taken in the ratio 2:3 by weight. Higher ratio by weight of alkali means calcium hydroxide over here, is taken higher ratio of, so this is 2 ratio and this is 3 ratio. Higher ratio of alkali is taken because it may counteract the loss of sublimation of NH4Cl. That means if you have lower ratio of calcium hydroxide, then it might result in the formation of ammonium chloride. So we don't want that. So we want that mostly whatever ammonia is formed, it is in higher quantity. Then calcium hydroxide is used as an alkali here because it is cheap and not deliquescent like other alkalis. You know what is deliquescent, right? It does not absorb moisture. Though all ammonium salts on heating with alkalis gives ammonia, yet ammonium nitrate, explosive in nature, and ammonium NH4NO2, क्या है ये? Ammonium nitrite, on warming with alkalis do not produce ammonia because they decompose on heating. So ammonium nitrate is explosive and ammonium nitrite does not give ammonia. So generally we don't use other salts to give ammonia. We only use ammonium chloride, not nitrates and nitrites. From metal nitrites, ammonia can also be obtained by the action of warm water on nitride of metals like magnesium or aluminium. This method is costly, so it is not preferred. But in that method, what do? They take magnesium nitride plus water. It gives magnesium hydroxide plus ammonia. Straightforward method. Aluminium nitride plus water gives aluminium hydroxide plus ammonia. What is the procedure? Magnesium nitride or aluminium nitride is kept in a round bottom flask fitted with a thistle funnel and a delivery tube. And warm water is added very slowly ammonia gas is liberated and the magnesium hydroxide or aluminum hydroxide formed, but it remains in the flask, and liberated ammonia gas escapes through the delivery tube. It is passed through drying agent and collected by downward displacement of air. Preparation of aqueous ammonia. Aqueous ammonia means liquor ammonia, that is aqueous solution of ammonia. So aqueous solution of ammonia is prepared by dissolving ammonia over water, in water. The rate of dissolution of ammonia in water is very high. Therefore, back suction of water is possible. You already know what is back suction. Back suction is the same thing which could occur in the case of HCl. So here also we use that inverted funnel method. To avoid this, a funnel is attached to the outer end of the delivery tube with a rubber tubing. The process is similar to the method used to change HCl gas into hydrochloric acid. So this is how it is done. We have ammonium chloride here and calcium hydroxide, and they are heated, and ammonia is formed and is passed through the delivery tube into the funnel, which is kept just over the surface of the water in a trough, and the back suction occurs up to a certain limit, and the water falls down and the ammonia keeps on dissolving into the water. यहाँ पे पूरा प्रोसीजर लिखा हुआ है. Water is taken in a container and only a small portion of the mouth of the funnel is dipped in water. As ammonia dissolves in water at higher rate than its production in the flask, the pressure in the funnel above the water level decreases for a moment and water rushes into the funnel. As a result, the rim of the funnel loses its contact with water. Since ammonia produced pushes the water down, the funnel comes in contact with water again. In this way, ammonia dissolves in water without back suction of water. Manufacture of ammonia, Haber's process. This is very important. This is industrial process of manufacture of ammonia, Haber's process. So this is the, you can say, flow chart of Haber's process. So in this process, you can understand everything from this flow chart. I will explain first and then I will read. So the reactants are nitrogen from liquid air, 1 volume, and hydrogen by Bosch process, 3 volume. Bosch process you have studied in class 9. Okay, so we have two of our constituents of ammonia, nitrogen 1 volume, hydrogen 3 volume. They are put into a compressor where they are compressed together. Then they are passed into a catalytic chamber where there is a catalyst at 500 degrees Celsius and 250 atmospheric pressure, and onto a cooling chamber. And from cooling chamber, again some of the constituents which are not mixed, they are passed into compressor and again into the catalytic chamber. And through the cooling chamber, liquid ammonia comes out in the combined form. So that's the process of making ammonia. Sources of reactants, nitrogen gas, it is obtained by fractional distillation of liquid air. अभी यही चीज मैं तुम्हें डिटेल में बताने वाला हूँ. Hydrogen gas is obtained from water gas or Bosch process or from natural gas. The reaction is N2 plus 3H2 gives 2NH3 plus heat. This is a reversible reaction. The reaction is reversible, exothermic, and proceeds with a decrease in volume. Favorable condition. Optimum temperature is 400 to 500 degrees Celsius, 450 to 500, and pressure is above 200 atmosphere. Catalyst should be finely divided ion. There is a star here. Finely divided catalyst has more surface area, and this increases the efficiency of catalyst. Promoter. The traces of molybdenum or Al2O3 acts as promoter. Rate of conversion. About 15% of the reacting gases get converted to ammonia. Recovery of ammonia. Ammonia is separated from the unreacted nitrogen and hydrogen by liquefaction. Ammonia has a much higher boiling point as compared to nitrogen and hydrogen, so it condenses easily. क्या वो बोर हो रहे हैं? अच्छा, नहीं हो सकता है बोर, ऐसा कोई जरूरी नहीं, ये है बोरिंग, ठीक है, बट कुछ नहीं कर सकते, थोड़ा सा इंटरेस्ट लो. Absorbing in water, because ammonia is highly soluble in water while नाइट्रोजन एंड हाइड्रोजन आर वेरी वेरी स्लाइटली सोल्यूबल. मतलब अमोनिया को अगर मुझे रिकवर करना है, रिकवर मतलब मुझे अमोनिया ऑब्टेन करना है इस प्रोसेस से, तो दो चीजें कर सकता हूं, या तो उसको लिक्विफाई कर सकता हूं कूलिंग से, या तो उसको वाटर में डिसॉल्व कर सकता हूं. तो दोनों तरीके से नाइट्रोजन और हाइड्रोजन जो अनकंबाइंड थे वो सेपरेट हो जाएंगे. प्रोसेस में क्या होता है देखो, नाइट्रोजन एंड हाइड्रोजन, यहाँ पे नीचे फ्लो चार्ट भी दिया है बहुत अच्छे से, ये भी अगर देख लोगे जब मैं पढ़ रहा हूं तो तुम्हें समझ में आ जाएगा. नाइट्रोजन एंड हाइड्रोजन आर ड्राइड एंड प्यूरिफाइड एंड देन मिक्स्ड इन द रेशियो ऑफ 1:3 रिस्पेक्टिवली एट अ रिलेटिवली हाई प्रेशर. दिस मिक्सचर इज पास्ड इन एन इलेक्ट्रिकली हीटेड कैटालिटिक चेम्बर. ठीक है, इसको पहले हाई प्रेशर से कंप्रेस करके कैटालिटिक चेम्बर में भेजते हैं. इसमें फाइनली डिवाइडेड आयन होता है जिसके साथ एल्यूमिनियम ऑक्साइड या फिर मोलिब्डेनम होता है एट अ टेम्परेचर ऑफ 500 डिग्री सेल्सियस. मिक्सचर ऑफ अमोनिया इज फॉर्म्ड, तुरंत फॉर्म हो जाता है अलॉन्ग विद द रेसिड्यूअल नाइट्रोजन एंड हाइड्रोजन. हाँ, लेकिन सारा अमोनिया फॉर्म नहीं होता है, कुछ नाइट्रोजन एंड हाइड्रोजन अभी भी अनकम्बाइंड है. ठीक है, दे एक्सचेंज देयर हीट विद द इनकमिंग अनरिएक्टेड नाइट्रोजन एंड हाइड्रोजन मिक्सचर. द हॉट मिक्सचर ऑफ द आउटगोइंग गैसेस कंटेन्स 15% of ammonia. The mixture is passed through cooling pipes or condenser. Ammonia liquefies first, whereas nitrogen and hydrogen do not liquefy easily. The unchanged nitrogen and hydrogen are recirculated or again sent through the plant to get more ammonia. By recirculating in this way, the eventual yield of 98% can be achieved. The ammonia produced is stored as liquid under pressure. The reaction is exothermic, hence low temperature will favor the synthesis. However, at low temperature, the reaction proceeds slowly. In practice, optimum matlab ideal, temperature has been found to be in the range of 450 to 500 degrees Celsius. 4 volumes of reactants produce 2 volumes of product. Hence, high pressure favors the formation of ammonia. The optimum pressure is found to be 200 to 900 atm. Practically, a pressure of 250 atm is used. Catalyst and promoter. Speed of reaction can be improved by using a catalyst, which is finely divided iron, obtained by reduction of iron oxide. A promoter, molybdenum or aluminum oxide, is also used to increase the efficiency of catalyst. Since the reaction is exothermic, the heat evolved further maintains the temperature. External heating is therefore not required after the reactants are initially heated. तो एक बार heat करने के बाद बार बार हम heat नहीं करते हैं. The purification of nitrogen and hydrogen is necessary as impurities like carbon dioxide, carbon monoxide, and traces of sulfur compounds poison the catalyst. The removal of these catalytic poisons from nitrogen and hydrogen is very essential. मतलब ये नाइट्रोजन और हाइड्रोजन को कंप्रेस करने से पहले हम उसको प्यूरिफाई करके फिर डालते हैं अंदर. So that was the first part. Now comes the physical and chemical properties of ammonia. It is colorless, ammonia. It has strong pungent choking smell like public toilets. Taste is slightly bitter. Who tastes public toilets? I don't know. Who does that? Public toilet में जाके लोग ऐसे क्यों करेंगे? Yes, slightly bitter. Yes. Now I get it. Okay. Physiological action. It is non-poisonous. आज तक कोई मरा नहीं है पब्लिक टॉयलेट में. Non-poison आपको इसीलिए तो है. If inhaled, affects the respiratory system and brings tears to the eyes. brings tears. मैं क्यों आया यहाँ पे? It is a powerful heart stimulant and may cause death when inhaled in large quantities. सो लोग तुरंत अंदर जाके तुरंत हाथ धोए बिना बाहर निकल जाते हैं, अदरवाइज हार्ट अटैक आएगा भाई। ठीक है। Density, vapor density is 8.5, very lighter than air. It is alkaline in nature, not acidic. Liquefaction, easily liquefied at 10 degrees Celsius by compressing it at 6 atm pressure. Boiling point, liquid ammonia boils at minus 33.5 degrees Celsius. Freezing point, solid ammonia melts at minus 77.7 degrees Celsius. Solubility, high solubility in water, 1 volume of water dissolves 702 volumes of ammonia at 20 degrees Celsius and 1 atmosphere pressure. More soluble than HCl. HCl was just 452 volumes. Fountain experiment, do I have to explain this? This is exactly same as earlier. To show that it is highly soluble in water and it is alkaline in nature. So we take red litmus solution, not blue. And we see a blue color fountain, not red. So drop, few drops go up, most of the ammonia get dissolved, creates a less pressure. Atmospheric pressure pushes the red litmus solution through the jet tube or the pipette into the round bottom flask, creating a fountain, which you can see in hundreds of YouTube videos are there. कभी डाल के देखो, समझेगा तुम्हें, फाउंटेन एक्सपेरिमेंट। ठीक है, सो ये भी हो गया। अच्छा ये देखो, a bottle of liquor ammonia should be opened very carefully only after cooling it in ice or cold water. There is high pressure inside the bottle of ammonia and on cooling the pressure drops. This prevents sudden flushing out of the gas. Sudden flushing out से क्या क्या हो सकता है हमको सबको पता है, हार्ट अटैक, टीयर्स इन द आईज। ठीक है। केमिकल प्रॉपर्टीज ऑफ अमोनिया, सबसे पहले थर्मल डिसोसिएशन। Ammonia gas dissociates into nitrogen and hydrogen at high temperature by electric sparks. Dissociation. Basic properties. Dry ammonia is covalent molecule, so it is neutral even in liquefied form. Its aqueous solution is a weak base. The basicity is due to lone pair of electrons on its nitrogen atom. An aqueous solution of ammonia is weak base. It dissociates partially to give hydroxyl ions. The alkaline behavior is due to hydroxyl ions, OH minus. ठीक है, so action on indicators दिया है. Moist litmus paper turns from red to blue with ammonia. Methyl orange turns from orange to yellow, and phenolphthalein turns from colorless to pink when it comes in contact with ammonia. Reaction with acids. Ammonia being a weak base accepts protons or hydrogen ions to form ammonium ions. It reacts with acid to form ammonium salt. So ammonia reacts with any acid to form ammonium salt, ammonium chloride, ammonium nitrate, or ammonium sulfate. Very easy pattern. Ammonium chloride is a good example where two colorless gases react to form white solid directly. कहाँ पे पढ़ा था ये? HCl में। फिर से कहाँ पे आया? अमोनिया में। कितनी कॉमन चीज है ये। सेम चीज तुम्हें एसिड बेसिस सॉल्ट्स में भी मिल जाएगी। सो अमोनियम नाइट्रेट एंड अमोनियम क्लोराइड बोथ शो, एक मिनट ये कहां से आया? ओके, थर्मल डिसोसिएशन के बारे में बात किया है। और यहां पे व्हाइट सॉलिड वाला, हाँ व्हाइट सॉलिड वाला ये है, NH3 plus HCl gives NH4Cl, solid. Two gases react to give a solid. The same salts which are produced by action of ammonia and acids are produced if ammonia is first dissolved in water to form ammonium hydroxide. So ammonia plus water gives ammonium hydroxide, and when ammonium hydroxide reacts with those acids, same salts are formed, but this time water is also formed with it. Earlier it was just the salt, now it is salt plus water. So it is a neutralization reaction. Reaction with soluble metal salts. Ammonium hydroxide reacts with soluble salts of metal to give insoluble precipitates of their respective metallic hydroxides, except sodium and potassium. This behavior is similar to a sodium hydroxide solution and potassium hydroxide solution. The precipitate formed by different metallic hydroxides differ in color and solubility. Hence, ammonium hydroxide is used in qualitative analysis for identifying cations. कौन सा चैप्टर है ये? Precipitates formed by different metallic hydroxides differ in color and solubility. Hence, ammonium hydroxide is used in qualitative analysis. Which chapter is this? Analytical chemistry. You remember the two reagents? एक तो अमोनियम हाइड्रोक्साइड था, एक सोडियम हाइड्रोक्साइड था. सो ये सारे वही कलर है. ये जो पूरा टेबल है ना, यहां से यहां तक, the whole table, this is from where? From analytical chemistry. Same thing is repeated here. Reaction with oxygen, this is important. This was not studied earlier in any other chapter. Ammonia is not a supporter of combustion. It extinguishes a burning splint and does not burn in air. It burns in oxygen with yellowish green flame. इसका flame का color याद रखना. Burning of experiment in oxygen, ये एक experiment दिखाया है. Ammonia plus oxygen gives nitrogen plus water vapor. A wide glass tube is fitted with a cork carrying two tubes, one of which reaches just near the top and other remains lower. Ammonia is passed through the longer tube and oxygen is through the shorter tube, and lighted match is applied. Observation: ammonia burns with yellowish green flame and produces water vapors and nitrogen. It shows that ammonia contains nitrogen and hydrogen. The reaction is irreversible and strongly exothermic. Mixture of ammonia and oxygen is explosive and therefore dangerous. ठीक है, टॉयलेट में कभी भी लाइटर लेके नहीं जाना, एक्सप्लोजन भी हो सकता है. मतलब टॉयलेट में क्या क्या नहीं करना, इसकी पूरी जानकारी हमको इस चैप्टर से मिल गई. Catalytic oxidation of ammonia, this has a huge chemical part, chemical properties wala part. In the presence of platinum at 800 degrees Celsius, ammonia reacts with oxygen to give nitric oxide and water vapor. So what you have to do to get nitric oxide? Pass dry ammonia gas and oxygen gas through inlets over heated platinum. देखो, dry oxygen, ammonia, inlet, platinum which is heated, placed in a combustion tube, which in heated state emits reddish glow. And you will find water droplets. NO plus O2 will give NO2 inside this round bottom flask. So you get a brown gas as a, you can say, the final product. Reddish brown vapors of nitrogen dioxide are seen in the flask due to oxidation of nitric oxide. So nitric oxide plus oxygen gives nitrogen dioxide, which is brown in color. The platinum catalyst continues to glow even after the heating is discontinued, since the catalytic oxidation of ammonia is an exothermic reaction. So इसका नाम ही है catalytic oxidation of ammonia. Reaction of ammonia with oxygen, not burning, not combustion. ये रिएक्शन ऑफ ऑक्सीजन में कंबशन था और ये वाले रिएक्शन में कैटालिटिक ऑक्सीडेशन था. इसमें ब्राउन गैस बना, नाइट्रोजन डाइऑक्साइड. The platinum catalyst continues to glow even after heating is discontinued, since catalytic oxidation of ammonia is an exothermic reaction. Reaction with carbon dioxide. Ammonia reacts with carbon dioxide at 150 degrees Celsius and 150 atm pressure to give urea, which is valuable nitrogenous fertilizer. So ammonia plus carbon dioxide at this conditions gives urea plus water. Ammonia is a reducing agent. Reduction of chlorine to hydrogen chloride. When chlorine reacts with ammonia, it is reduced to hydrogen chloride, which further combines with excess of ammonia to form NH4Cl. देखो, so first 2NH3 plus Cl gives N2 plus HCl. Then 6NH3, when NH3 is in excess, 6NH3 plus HCl gives NH4Cl. So we get 8NH3 plus 3Cl gives N2 plus 6NH4Cl. ऑब्जर्वेशन, इसी का ऑब्जर्वेशन मतलब रिड्यूसिंग प्रॉपर्टी का. The yellowish green color of chlorine disappears and white fumes of ammonium chloride are formed. When chlorine is in excess, then the products are hydrogen chloride and yellow colored highly explosive liquid nitrogen trichloride, NCl3. These reactions show that chlorine has a great affinity for hydrogen and ammonia is a reducing agent. Remember. Reduction of metallic oxides. Ammonia reduces heated metallic oxide to give metals, water vapor, and nitrogen. Pass ammonia gas over heated copper oxide in a hard glass tube. You will get copper, hydrogen plus nitrogen gas will be evolved. The black copper oxide is reduced to reddish brown copper. Similarly, ammonia reduces heated yellow lead monoxide to grayish metallic lead. Same kind of reaction. Collection of gas. Nitrogen, which is collected over here, is collected in water in a gas jar because it is sparingly soluble in water. The water formed is collected in the U tube and is tested with anhydrous copper sulfate, which turns blue. This reaction proves that ammonia is made up of nitrogen and hydrogen and is therefore nitrogen hydride. Okay. Now something important, tests for ammonia gas and ammonium ion. Ammonia gas can be easily recognized by following characteristics. It has a sharp characteristic odor. It turns moist red litmus blue, turmeric paper, brown, turmeric paper, and phenolphthalein solution pink. It gives dense white fumes with concentrated hydrochloric acid. हमने पहले ही पढ़ा था ये. When ammonia is passed through copper sulfate solution, blue precipitate is formed which changes to deep blue solution on passing the gas in excess. Analytical chemistry. All ammonium salts generally produce ammonia gas when warmed with alkali like sodium hydroxide. Ammonium salt gives brown color or precipitate with Nessler's solution K2HgI4. A slightly alkaline solution of potassium mercuric iodide made by adding KOH. मतलब कुछ भी रैंडम फैक्ट्स है जो एक साथ ये लोग ने कंपाइल कर दिए. रैंडम है बिल्कुल, इसका आगे पीछे हमको कुछ आइडिया नहीं है, बट वी हैव टू रिमेंबर. एनीवेज, यूजेस ऑफ अमोनिया. Liquid ammonia is used as a refrigerant in ice plants. So there are many ice plants where ice is made, where liquid ammonia is used as a refrigerant. Liquid ammonia takes a lot of energy to vaporize. This heat taken from the surrounding bodies, which are consequently cooled down. So जो भी कंटेंट है रेफ्रिजरेटर का उसको कूल डाउन करता है. दिस इज नॉट योर होम रेफ्रिजरेटर, ठीक है, उसमें अलग कूलेंट यूज होता है. दिस इज इंडस्ट्रियल रेफ्रिजरेटर. Anhydrous ammonia is a clear colorless liquid under pressure. It evaporates rapidly and produces cooling effect. This makes ammonia a good refrigerant. The main refrigerants used are freon chlorofluorocarbon, CFCs, which produces that ozone depletion. They deplete ozone layer and also contribute to global warming. Thus, these refrigerants are harmful to life. The chlorofluorocarbons are decomposed by ultraviolet rays. ये सब तुम्हें 9th में पढ़ा था, इसको फिर से पढ़ने की जरूरत नहीं है. ओजोन लेयर कैसे डिप्लीट होता है उसके बारे में, ठीक है. एडवांटेज ऑफ अमोनिया एज अ रेफ्रिजरेंट. क्यों अमोनिया यूज करना चाहिए? अमोनिया इज एनवायरमेंटली कंपैटिबल, so compatible that it's also found in toilets. ठीक है. It does not deplete ozone layer and does not contribute to global warming. How can it? नहीं तो अब सब मर चुके होते अब तक. इतने लोगों ने रोज का क्या बोलूं. It has superior thermodynamic qualities. As a result, ammonia refrigeration systems use less electricity. Means वो कम एनर्जी यूटिलाइज करके ज्यादा हीट एब्जॉर्ब करता है, ज्यादा कूलिंग प्रोड्यूस करता है. अमोनिया हैज रिकॉग्नाइजेबल ऑर्डर, सो लीक्स आर नॉट लाइकली टू एस्केप. वेरी ट्रू, वेरी ट्रू. फ्लश नहीं किया तुरंत समझ में आता है. Ammonia has some disadvantage. It is not compatible with copper. So it cannot be used in any system with copper pipes. Ammonia is poisonous in high concentration, although it is easily detectable due to its peculiar smell and also being lighter than air. It goes up into the atmosphere, not affecting the life too much on Earth. Directly up. Ammonia solution is used as an important laboratory reagent in qualitative analysis as it gives characteristic colored metallic hydroxide precipitate analytical chemistry. Uses of ammonia. Aqueous ammonia emulsifies or dissolves fats, grease. So it is used to remove grease and perspiration stains from clothes, for cleaning tiles and windows. मेरे दिमाग में बहुत अजीब अजीब ख्याल आ रहे हैं. Remove grease, perspiration and cleaning windows. Ammonia. Oh, फ्री में हो जाएगा काम. Ammonia is used in the manufacture of nitrogenous fertilizers like ammonium sulfates, diammonium hydrogen phosphates, ammonium nitrate, and urea. Explosives like ammonium nitrate are made from ammonia. Ammonium nitrate decomposes explosively, leaving no residue behind. This is the Beirut explosion, ammonium nitrate. Other ammonium salts such as ammonium carbonate used as smelling salt for reviving a fainted person. मतलब फेंटेड आदमी भी जाग जाता है. अमोनियम क्लोराइड मतलब स्मेल है, इसके पास एक चीज है स्मेल. आपका वेपन क्या है, आपका स्ट्रेंथ क्या है सर? मेरे पास स्मेल है. आई हैव स्मेल. आई कैन इवन रिवाइव अ फेंटेड पर्सन. ये अमोनिया जो इंटरव्यू देने जाएगा तो क्या बोलेगा? सर आप कहाँ पे रहते हो? मैं टॉयलेट में रहता हूँ. An interview with ammonia. You can do that यार. मस्त स्टैंड अप होगा ना. मस्त एक स्केच क्रिएट कर सकते हैं इसके ऊपर. ओके कूल. अगर मैं ये सब नहीं करता ना तुम लोग सो जाते. इसलिए सब करना पड़ता. मैं हर साल करता हूँ, तुम्हें पता नहीं है. हर साल. बट हर साल मुझे नए नए कंटेंट मिलते हैं इसी चैप्टर से. न्यू जोक्स एवरी टाइम. सर व्हाट इज योर हॉबी? सर आई क्लीन फ्लोर्स, विंडोज. It's too much. It's too much. I'm sorry. I think ये लाइव है कोई यहाँ पे? लाइव बच्चे थे. Connection was lost. Oh my god. They were actually they were saved. No internet. कैंसी इंटरनेट नहीं है? Oh, cool. एटलीस्ट रिकॉर्ड तो हो रहा है ये सब. रिकॉर्डेड होगा ये. ओके. Ammonium chloride used in dry cells and in the preparation of nitrogen gas. ठीक है. Nylon and rayon and sodium cyanamide, plastics, dyes, organic chemicals, explosives, and wood pulps are prepared by ammonia. Sodium carbonate by Solvay process. This process involves the interaction of ammonia, carbon dioxide, and sodium chloride in water solution, resulting in the precipitation of sodium hydrogen carbonate. So sodium chloride plus ammonia plus carbon dioxide plus water gives sodium hydrogen carbonate plus NH4Cl. The sodium hydrogen carbonate is separated and ignited to obtain sodium carbonate. And lastly, ammonia is used for preparation of nitric acid by Ostwald's process. मुझे याद है मैंने जब सल्फ्यूरिक एसिड पढ़ाया था तो ओस्टवाल्ड प्रोसेस तभी एक्सप्लेन किया था. ये किसी का तो डिमांड था. मतलब क्या बोलते हैं उसको, पब्लिक रिक्वेस्ट था एक, सब लोग ओस्टवाल्ड तो मैंने पढ़ाया था तभी, बट मैं फिर से बता रहा हूँ यहाँ पे. I'm teaching again because you might have forgot, so it's a good small thing, good revision for you all. A German chemist, Ostwald, in 1914 developed Ostwald process. The process is explained in 3 steps. Step number 1, catalytic oxidation of ammonia. A mixture of dry air free from carbon dioxide and dust particles and dry ammonia in the ratio 10:1. Okay, dry air 10 ratio में और dry ammonia 1 ratio में by volume is first compressed and then passed into the catalytic chamber containing platinum gauze as a catalyst at about 800 degrees Celsius. मतलब वो जो फर्स्ट वाली चेम्बर दिख रही है ना तुम्हें, दैट इज द कैटेलिटिक चेम्बर जहां पे एयर और अमोनिया का मिक्सचर 10:1 वॉल्यूम में पास किया जाता है. इट इज एट 800 डिग्री सेल्सियस एंड देयर इज अ प्लैटिनम कैटलिस्ट हियर. ठीक है. दिस रिजल्ट्स इन ऑक्सीडेशन ऑफ अमोनिया इनटू नाइट्रोजन मोनोऑक्साइड. ठीक है, इससे बनता है नाइट्रोजन मोनोऑक्साइड. द रिएक्शन इज एक्सोथर्मिक एंड द हीट इवॉल्व मेंटेन्स द टेम्परेचर ऑफ कैटालिटिक चेम्बर. The hot gases are then passed through a heat exchanger when they are mixed with air and passed into another cooling chamber called oxidizing chamber. तो इसके बाद हीट एक्सचेंजर से पास करते हैं हॉट गैसेस को. जनरली हॉट गैसेस में नाइट्रोजन मोनोऑक्साइड और वाटर वेपर होता है. फिर कूलर में भेजते हैं जहाँ पे वाटर का स्प्रे होता है, उसको कूल किया जाता है. देन ऑक्सीडेशन ऑफ नाइट्रिक ऑक्साइड इन ऑक्सीडेशन चेम्बर. अब ऑक्सीडेशन चेम्बर में क्या होता है, ऑक्सीडाइजिंग चेम्बर या ऑक्सीडेशन चेम्बर. इसमें नाइट्रोजन मोनोऑक्साइड ऑक्सीजन के साथ रिएक्ट करता है एट 50 डिग्री सेल्सियस टू गिव नाइट्रोजन डाइऑक्साइड. उसके बाद ये नाइट्रोजन डाइऑक्साइड को वाटर में डिसॉल्व किया जाता है. The nitrogen dioxide together with remaining air, sometimes more air is added at this stage, is passed through absorption tower, a steel tower fitted with quartz stone packed in layers, from the top of which warm water trickles. The nitrogen dioxide and oxygen present in the air react with water to form nitric acid. तो ये water nitrogen dioxide और oxygen के साथ react करके nitric acid बनाता है. The nitric acid obtained at the bottom of the tower is concentrated above 50 degrees Celsius. The above acid on further distillation gives 68% pure nitric acid. This acid is concentrated nitric acid which is used in laboratories. Concentration of nitric acid up to 98% concentration. Fuming nitric acid is obtained by distilling 68% HNO3 over concentrated sulfuric acid. Pure 100% nitric acid is obtained by strongly cooling 98% acid when colorless crystals of pure nitric acid get separated at -42 degrees Celsius. In the manufacture of nitric acid, higher ratio of air is used because oxygen is only 1/5 in the air and it is required in all the 3 chambers. And quartz is used in the last absorption tower because it is acid resistant and when packed in layers it helps in dissolving nitrogen dioxide uniformly with water. तो ये पूरा फ्लो चार्ट है ओस्टवाल्ड प्रोसेस का, जो जो हमने पढ़ा सारे रिएक्शंस के साथ. यू नीड टू रिमेंबर इट एंड इन द एंड यू गेट नाइट्रिक एसिड. और ये कॉन्सेंट्रेशन के बारे में भी कुछ डिटेल्स हैं. सो दिस वाज योर अमोनिया. 2 chapters done. 45 minutes again.